Hi friends, welcome back. Today we are going to build this binary clock, which is basically a time incrementer using the Arduino and this 74HC595 shift register IC. And these LEDs are representing the binary time. So in this video I will make use of millis function, which keeps track of time, and I will also explain the detailed working of this IC with the help of GUI based visualization. So let's get started. So before moving further, let us discuss about the brief of this shift register IC. So this IC is basically a pin multiplier chip for a microcontroller, and it allows us to control 8 different things like LEDs using only its 3 pins. So if you are falling short of the pins on a microcontroller, you can use this IC in this case. Let's say you have only 5 pins left. So you can use any of the 3 pins and connect them to this shift register IC, and you can drive all the 8 outputs. So what are the 3 pins on this IC? Those are this pin number 14, also called as SCR or data pin. So on this pin, data comes from your microcontroller. The second pin is this RCLK, and the third one is this SCLK, right? So all these 3 pins allow us to control 8 different outputs. So shift registers are mainly of 4 types: series in, series out, series in, parallel out, parallel in, series out, and parallel in, parallel out. So the first property represents that how data is coming from the microcontroller, and the second property represents that how data is exiting from the chip. So this chip is basically this type: series in, parallel out, because on this pin number 14, which is the data pin, the data comes from the microcontroller bit by bit, I mean serially. Okay, so this is serial, and it can drive all the 8 outputs Q0 to Q7 simultaneously, or you can say parallelly. That is why it is series in, parallel out. Now this is the working flowchart of the shift register IC. So step 1 starts by pulling the latch pin to low by the microcontroller to make sure the IC remains ready for receiving the data. So this latch pin on this IC is this one, pin number 12, RCLK. The second step is the data comes on the DS pin or the data pin of the IC. And note that this data will be of binary type, either 0 or 1. The third step is the clock pin starts. So this pin is the clock pin, SCLK, pin number 11. So this pin starts to send the pulses. So here comes the two types of concepts. The first one is the MSB and the second one is LSB. So the leftmost bit is the MSB and the rightmost bit is the LSB. So if you are sending the bits from the right side, that means you are sending LSB first, and if you are sending the bits from the left hand side, you are sending the MSB first. So on the pulse 1, this 0 will be shifted to Q0 position. So I am using the MSB. And in the second pulse, this 1 will be shifted to Q0 and the previous 0 will be shifted to Q1, right? And in the third pulse, this new 1 will be shifted to Q0, this previous 1 will be shifted to Q1, and the 0 will be shifted to Q2. So in every pulse, the new data which comes from the microcontroller is shifted to Q0 first, and the previous all the bits are shifted to next position. And the last step is the latch pin is pulled to high by the microcontroller to stop the shifting of the bits. And note that the number of pulses will be equal to the number of bits that you want to send. Let's say you want to display only 5 bits of data on the output pins, right? So you will require only 5 pulses. So this is the GUI based visualization which will display the shifting of the bits. So I will display this data on the output pins Q0 to Q7, and I will use MSB first. So when you are using MSB and after sending all the pulses, the MSB is present on the Q7 output and the LSB is present on the Q0 output. So let's pull the latch pin to low and the bits are ready to be shifted. So let's send one pulse. Okay, so you can see on the data pin 1 is coming. After sending second pulse, the second bit is coming on the DS pin, right? So after sending all the pulses, you will get the final output. So you can see I have sent all the pulses and this is the final output. Now let's pull the latch pin to high, and this is the final output: Q0, Q1, Q2, Q3, Q4, Q5, 6 and 7. Now let's see how the wiring order will get reversed if you are using LSB. So in case of MSB, I am connecting this LED to Q0, this one to Q1, this Q2, Q3, Q4 and Q5. But if you are using LSB first, then the wiring order will be changed. You will connect this LED to Q0 first, this one to Q1, Q2, Q3 and Q4, Q5. Okay. So this is the difference between the wiring order between both the cases. So in the program, we are defining all the 3 pins of the IC: data pin, clock pin and the latch pin. And these are the timing variables, previous millis and the seconds. So we are going to display only 60 seconds. And in the loop function, we are calling these functions update time and display seconds. So update time, if the time difference between the current time, millis gives you the current time since the microcontroller started to run. So if the time difference between current and the previous time is greater than 1000 milliseconds, it means 1 second, then we are updating this previous millis with the increment of 1000, and we are increasing the second by 1. So if the seconds is greater than 60, it means we are resetting the time to 0. And this is a function display seconds. So you can see we are pulling the latch pin to low and we are shifting the bits one by one using this function shift out. So we are inputting the data pin, clock pin here, and we are sending the MSB first. You can also use LSB, but in that case the wiring order will get reversed. And after that we are pulling the latch pin high. So if you want to keep on getting these kinds of tutorials in future as well, then subscribe for more. And if you want to upgrade this project with RTC module or with the reset button, then let me know in the comment section. And thanks for watching this video. I will see you in the next one.